we need to verify that the area of a triangle is invariant under the translation of the axis. Let us begin. Now we'll start with a triangle ABC. So let the vertices of the triangle be ABC have the coordinates A, x1, y1. Coordinates of vertex B, let it be given by x2, y2. And the coordinates of vertex C, so let it be given by x3, y3. Then the area of the triangle will be, we're going to represent it by delta, so that's given by half times the absolute value of, so we'll start with x1 and multiply it with y2 minus y3. Then add it to x2 multiplied to y3 minus y1 plus x3 multiplied to y1 minus y2. So this is the area of the triangle. So we're going to label this as equation number 1. Now, what we're going to do, we're going to translate the axis. So translation of the axis means we're going to shift the origin. Now here equation number 1 is with respect to the x and y axis, meaning its origin will be at the point O, and we suppose that it's at 0, 0. Fine. Now what we're going to do, we're going to translate it, means we are going to shift the origin. So shifting the origin from the initial position O to a new position O prime such that it has the coordinate at h, k. If this is the case, then we'll have to make the transformation. Then x is going to be replaced with x plus h, and y is going to be replaced with y plus k. Now here, x and y, this x and y, which is represented in uppercase letters, so these are the new x's. Now what we'll do, we'll try to find out the area of the triangle with respect to this new axis. Now let's do one thing. So here, and this is the transformation. So this would mean, so we're going to generalize this case. So that means we can, x1 will be equals to x1 plus h. Then x2, that will be equals to x2 plus h. So here h is fixed because we're not doing any rotation here. We're only doing translation. So x3 is going to be x3 plus h. Similarly, we can define for y1, y2 as well as y3. So y1, that's going to be equals to y1 plus k. y2, that will be equals to y2 plus k. And then y3, that's going to be y3 plus k. Now what we'll do, we'll substitute these values of x1, x2, x3, y1, y2, and y3 into equation number 1. But before doing that, let's do one more thing. So let's find out the value of y1 minus y2. Now clearly y1 minus y2, that's going to be y1 plus k minus y2 plus k. So when I simplify this, we're going to get y1 minus y2. Similarly, we can do it for y2 minus y3. So y2 minus y3, that's going to be y2 minus y3. And then we have y3 minus y1. So that will correspond to y3 minus y1. So let's substitute this value back in equation number 1. So equation number 1, the new triangle, because we're doing a transformation here. So it's no longer going to be delta, but it's going to be delta prime. So delta prime is going to be half multiplied to the absolute value of x1. So x1 is going to be replaced with x1 plus h. And this will be multiplied to, we need y2 minus y3, but after transformation, we have y2 minus y3. Added to x2, so x2 will be x2 plus h multiplied to y3 minus y1. Added to, now we need x3, so x3 is going to be x3 plus h multiplied to y1 minus y2. So we're going to simplify this expression within the absolute value. So we have half times the absolute value. So now we're going to multiply x1 with y2 minus y3. So that leaves us with plus h times y2 minus y3. Plus we have x2 multiplied to y3 minus y1. And we have h multiplied to y3 minus y1. Plus we have x3 multiplied to y1 minus y2. Plus h multiplied to y1 minus y2. Fine. So this will be equals to half multiplied to we have x1 multiplied to y2 minus y3 plus x2 multiplied to y3 minus y1 plus x3 multiplied to y1 minus y3. Now we're going to combine these terms by taking h as the common factor. So if we take h as the common factor, so this will get multiplied to, we have y3 minus y2 minus y3 added to y3 minus y1 plus y1 minus y2. Fine. So here we can see that all the terms inside the parentheses get cancelled out. So that means this entire expression goes to 0. Now we are only left with half times the absolute value of x1 multiplied to y2 minus y3. Then this will be added to x2 multiplied to y3 minus y1 plus we have x3, so that will be multiplied to y1 minus y3. Fine. So now what we have obtained, this is the area of the triangle after translation or after the shifting of the origin, and we see that it has, so let's call it number 2. So this number 2, equation number 2, this is having the same form as the original area of the triangle. It has having the same form. So since it is having the same form, that only tells us that even after shifting of the origin or after the translation of the axis, the area of the triangle has remained unchanged. That means the way how we calculate the area of a triangle, so that has remained unchanged. So it is invariant, hence proved.